What is the result if you collide light with the same intensity and same wavelength? When light waves with the same amplitude and wavelength collide, they exhibit interference phenomena. Interference is the phenomenon where two waves meet and either reinforce or cancel each other out. When two waves reinforce each other upon meeting, it results in constructive interference. Constructive interference occurs when the phase difference between the two waves is 0 degrees, leading to the combined amplitudes of the waves creating a larger amplitude wave. When two waves cancel each other out upon meeting, it results in destructive interference. Destructive interference occurs when the phase difference between the two waves is 180 degrees, causing the amplitudes of the waves to cancel each other, resulting in a wave with zero amplitude. Therefore, when two beams of light with the same intensity and wavelength collide, they produce alternating interference patterns of constructive and destructive interference. In regions of constructive interference, the light's intensity is stronger, leading to bright areas. In regions of destructive interference, the light's intensity is weaker, resulting in dark areas. These interference phenomena provide significant evidence of the wave nature of light. In actual experiments, one can observe light interference patterns by, for example, passing light through two slits to observe an interference pattern. Additionally, one can shine a beam of light onto an object to observe interference patterns. Light interference phenomena find various applications in the field of optics. For instance, lasers are created using the principles of light interference. Furthermore, holography is an imaging technique that relies on light interference to create three-dimensional images. When light waves with the same amplitude and wavelength collide, they do not pass through each other, and they do not affect each other. This is because light exhibits wave-like properties, and waves interact by either adding or subtracting their amplitudes while passing through each other. Therefore, light waves with the same amplitude and wavelength do not interact with each other as their amplitudes do not add or subtract from one another. In practice, the observation of the collision of light waves can be conducted as follows. By directing two lasers to face each other and causing them to collide, the two lasers pass through each other without affecting one another. When observing the interference pattern created by the collision of these two lasers, it confirms that they do not influence each other and continue unaffected. However, the collision of light waves can also result in the following phenomena. 1. Interference. Two light waves interact by either adding or subtracting their amplitudes as they pass through each other. 2. Scattering. Light changes direction when it collides with particles. 3. Absorption. Light is absorbed by matter. These phenomena arise from the dual nature of light, possessing both particle-like and wave-like characteristics. Therefore, the collision of light waves demonstrates both the wave-like and particle-like properties of light.